I'm not worried about that.
Hey, good afternoon, everyone. My name is Adnan. I'm one of your room hosts. I just have some important housekeeping information to share with you. Emergency exits are out the back to your left. The restrooms are out the back towards your right. And just remember to silence your devices during the session. That would be really great. And then just please remember to share your feedback after the session as well. For this session, extracting fresh insights from your data with the latest AI and ML tools, please welcome to the stage Anne Merrihew, Brian Knotts, Jeff Olson, and Noah Rowland.
Thank you.
Thank you. I am so impressed that you are all here, and it's the last day of the summit, and it's the afternoon. Congratulations, you've made it through this. It's a big week, isn't it? It's such a pleasure to have everyone here, and I love the fact that we're going to be talking about ML and AI today, because every customer that I work with brings it up in one way or another. So let me formally introduce myself. I'm Anne Merrihew. I'm the Director of Higher Education for Amazon Web Services. I've worked at Amazon for about 7.5 years, and I jokingly say that we at Amazon consider years in terms of dog years, so I've been at Amazon for a little over 50 years. And it feels like that much for how much we've seen the business grow and get clearer and clearer on what the customer needs are. So today we're going to be talking about machine learning and AI and how do you get data and extract important, insightful data for your customers. And if you read the session summary, we didn't tell you this, but what we chose to do was to focus on education. Because in education, we have so much data. Student data, what are we going to do with it? How do we help students? So I'm going to have the speakers today introduce themselves. But the idea here is really to focus on one specific vertical. It can be used across all. We wanted to get 3 different scenarios on how they're using ML and AI to make a difference for the people who work in their companies and for those customers who are actually using their products. When you think about ML and AI, and I've been in education all my life and I work with researchers all the time, when we first started really thinking about building something that was meaningful for the masses, what we knew was that machine learning really was for a very few. There were very few who knew how to do it. And as we became committed at AWS to really building something that made it easier for everyone with SageMaker and other products that we have come out with, other services, what we've found is that it's democratizing across the playing field for people to actually start using these services and to start getting insightful data. So we're really excited to talk about this. I think we've got some really interesting scenarios for you. And again, thank you so much for being here. So I'm going to ask each of you, and I'll make sure I stand to the side so that you can all hear me. I'm going to ask each of you to please introduce yourselves, and Brian, we'll start with you, and tell us a little bit what your role is and a little bit about Ellucian, because I think each of you do very different things within education and different companies. So Brian, if you'll start first, that'd be great.
Sure, thank you, and thank you for having me. So I'm Brian Knotts, I'm Chief Architect, and the way I like to describe my job is I have the best job in the company. So one of the things I get to work on are new ideas. I get to take those into research and then move them along into product development and so forth. So I'm going to tell you a little bit more about, I'm going to tell you some of the things that I wish I knew when I started my journey on AI/ML.
And tell us what Ellucian does, for those who don't know Ellucian.
Sure. So Ellucian has a portfolio of products for higher education. So mostly on the administrative side, predictive analytics, ERP systems, systems of engagement for CRM, and that type of family of systems. And we have about 2,500 customers in the space. So we're one of the industry leaders.
Perfect. Jeff.
So my name is Jeff Olson. I'll introduce myself in a moment, but first just a little bit about my organization. I'm from the College Board, and we are 119 years old. We were founded by a set of colleges with the intent to make access to higher education more equitable. And so eventually, in 1926, we created something called the SAT, which, we don't all like taking tests, but it allows students to be seen who were previously not seen when access to highly selective colleges was much more about going to fancy private high schools. And then later we created the Advanced Placement or AP program. Some of you may have taken AP courses, which provide access to college level courses to students while they're in high school. And one of the cool things we're doing is we offer courses in computer science. And we have something that we created called AP Computer Science Principles that's really about increasing gender diversity in software engineering. And it's off to a fantastic start here in the first few years. So that's a little bit about College Board. I started the data science practice at College Board 6 years ago and now lead a chunk of our software organization. But we've fused together data science with all software engineering because we think that over the coming 5 years or so, that they're going to be increasingly one thing.
Perfect. Great. Thank you. And Noah.
My name is Noah, and I'm a software engineer with EAB, and we are the Education Advisory Board. We focus on helping students kind of graduate on time, helping provosts and advisors figure out which students to talk to. We really focus on the kind of analytics side of the education industry, whereas Brian really helps generate the data with something like Banner, which is an SIS for universities. We try to take the data that Banner generates and really add on value, add on content, really give our institutions a fighting chance to kind of answer their questions with fact instead of just feeling and hunches.
Perfect. Thank you so much. So I'm going to be asking you questions. Sometimes they won't be questions for all of you, but with the first question, I actually want to hear from each of you because I think it would really help the audience to understand where you guys got started. What made you get into ML and AI? What kind of business problem were you trying to solve? And Brian, if you wouldn't mind going first.
Sure. So one of the things we had looked at, and I've looked at, I think you can see from my hair, I've looked at AI for many years, and so we were always intrigued by it, we were always looking at it, but it wasn't, it almost died, right, in terms of 10 years ago or so. And part of that was the fact that it was very hard for companies like ours to be able to bring the kind of compute power, the kind of processing, to hire the right kind of people, and to sort of bring the algorithms out from, say, the pure data science university environment and into more of a democratization of the data and be able to really start to add to the business. We were very intrigued with ML, and we still are in terms of all of the things that it can do. I think between the cloud and AI, these are two of the biggest events that have happened in almost the history of our company in terms of the magnitude of impact they're going to have for student success, the impact they're going to have on lowering administrative and actually purposing administrative duties more towards the students and less towards the administrivia. So those are a few things. And one of the things that we discovered pretty early on, and this is about 3 or 4 years ago, and really it started out, it's kind of interesting, it really started out as sort of a data problem for integration. So at the time, we were moving our systems to the cloud, and we realized that it was going to be very difficult for the way our industry was structured to be able to integrate with those systems, because there was still going to be a fair amount of things on-premise that we would have to connect, that you could imagine in ERP, CRM type systems would require to be able to really do this. So we started out with our program around what we call Ethos, which was to build out an enterprise data model, an enterprise data set, so that our customers could continue to be, or would be able to put their systems in the cloud, or our offerings would be in the cloud, and they could purchase those or move to those, and still be able to maintain that integration. Well, that corpus of data, one of the things I always look for in research is kind of a little bit of luck to have things kind of line up. That's something that I actually try to focus on, because I see that a lot. I'm looking for that. I almost call it a football, like it's sitting there for the taking. So as we started to get into the AI ML stuff in that same time frame, maybe a year or so later, we realized that we were sitting on, in the cloud, a large corpus of data that was in an enterprise mode. It wasn't just specifically for our systems. It was an enterprise data model. So our partners, as is sitting up here, and others could take advantage of this. And yet that actually has turned out to be the perfect foundation for our AI program. We're going to get into a little more of that discussion. But having harnessing that data and putting it into a structure so that you can launch it against an AI program is really probably a key insight. And as we get into a little bit more of this, when you start to discuss how you're going to do this, it always comes back to the data. And I think some of the things my colleagues are going to share will bear that out. But there's a large percentage of work just to get the data aggregated, get it into a position where you can study it. I'll stop there. I'll come back.
Yeah, no, that's perfect. I think it's really interesting what you said about, you've been studying AI for quite a long time, and it seemed like it was going to go somewhere, and then it didn't. And those of you who heard Andy talk today said, Amazon's been working on this for over 20 years. We've been using it. But what's interesting, I think, about what you said is that it wasn't until you started getting into the cloud that it made you stop and look at, wait, things are different. If we actually have the possibility of running as much as we need when we need it, being able to shut it down when you need it, it opens up the possibility of, well, what could we do with all this data now? We actually can put it, like you called it, a football right in front of you and say, I actually want to crunch some numbers on that. I want to see what that is and what more can I learn. So it's an interesting intersection, I think, that brought you into looking at ML and AI.
Just one quick point about that is when we were looking at this kind of space, we realized that the Googles and the Amazons and the IBMs and so forth could bring that kind of cost to bear and build that kind of compute infrastructure out for those companies, and companies like mine to try to monetize that sort of compute complex. And as we talk about the tools that we're using for like SageMaker and some of the foundational services to store a lot of data and then be able to study it in a cyclical model at higher education costs, really, so the cloud and that data together and the platform to manage that data, but then also to sit the AI technologies on top of it that we'll discuss a little bit, really brought that into a company like ours and made it possible.
Yeah, it's not just the top 10 companies in the world anymore. Everyone has access to it, and that's the whole point. So Jeff, I'd love to hear what was the compelling event or the reason why College Board decided to start down this path with ML and AI?
So, I mean, in a sense, we've been a statistical organization for over a century.
That's right.
Right? I guess I would stress, like, I have a little bit of an allergy to the hype that's going on around AI and ML at the moment. You know, we all know what I'm talking about, right? And so the thing I would stress, and it's true of our experience, is it's important that it should arise from real specific problems, from real questions that you want to answer. And that's the way to kind of get on the good foot. And that was the case for us. So I would say we had been exploring it for a time. And as might be true with most things, it began in a sort of consulting-y space, like let's try a project, let's see if we can add value, let's see if we can learn something. And only later did we get to a place where we could start building microservices that become sort of internally productized, right? So it starts from investigation of problems. And I'll give you an example of an early problem that we worked on. So we said, are we offering the SAT at the right times? We offer it 7 times a year. And we wanted to decide, well, is that optimal? And so we have a large corpus of data with which to work. And one of our data scientists, Melissa Donovan, she led this project to use machine learning to essentially simulate any possible calendar, many possible calendars, considering all sorts of measures of latent demand and availability and so on. And it kept coming out with this, and she ran it on AWS, and she ran hundreds of thousands of potential calendars and scored them in a variety of ways. And it kept saying that we should make the SAT be in August rather than in January. And that was super counterintuitive to us because don't you guys go on a vacation in August? And school's not in session and various other things. It's super counterintuitive, just something folks hadn't considered. And so we validated it a few ways, and we did end up moving the January administration of the SAT into August. And lo, from the very first time that we offered it, there was like not enough seating available. It was in such demand, and it's now one of the high demand times to take the SAT. But it was an example of how machine learning was able to identify something that our human eyes did not see.
Yeah, so it's interesting. So any of you who have children who are missing out on vacation in August because they're going to be taking the test, you can blame it on machine learning.
Yeah.
But I think it is interesting what you say, that this is why we're interested in machine learning. Sometimes the data will tell us things that we would not think are going to be true. And so it's really important to verify things with data, and that's what machine learning can do for us. So it's fascinating that that's where you started. Noah, I'd love to hear what the story was for your company.
I'll talk a little bit about what we kind of first started out with. We used to be part of a larger company, the advisory board, and we recently split healthcare and education. And our kind of flagship performance product was this tool that would help advisors target students that were in need of advising help. We wanted to help students improve their graduation timelines. We wanted to make sure they graduated on time, improve retention rates, this whole slew of problems that advising was facing. And we had a really smart guy working for us, and he built this entire system on top of a web app that was powered by a bunch of Excel workbooks. And they were really complicated. He was the only one that knew how they worked, and it was very difficult to kind of explain to our clients like why something was scored one way versus another. There was no follow-up. And so we said, this is a terrible system. It's not maintainable. If we lose Steve, then what happens to the product? We ended up taking that and moving it to a third-party vendor. We moved all of our ML out of the workbooks into kind of a scoring system, a more traditional machine learning model. And even that really wasn't enough. We were limited to scoring 2 models at a time. There was no parallelization. The cluster would go down all the time, and we didn't have any control. So recently, SageMaker came out, and we said, hey, this is a great opportunity for us to reevaluate our architecture for our flagship product. We don't want to invest all these resources into kind of redoing all this work without first trying it out. So we said, hey, we have a new product coming out that's designed to look at CRM systems and kind of figure out what pipelines of students are going to feed into universities. So let's try to use SageMaker for that. We took a bunch of lessons learned from that. We moved it back over to our flagship product. We reworked the entire system, and now we can run as many models as we want, as frequently as we want, all parallelized, and there's no bottleneck.
Well, and how's Steve doing?
He left the company
he left the company.
A year after we had that conversation.
Well, so I think this is the
so
reason.
It was a good move.
The reason why I love all these stories is like, this is the real world stuff. And I would just love to see a show of hands of anyone who has never been in a company where one person had access to all the data, and if that person was gone, someone would be in trouble. Right, there's not one hand that's up. So these are things that we as humans do to survive, and the fact is that we can do more. We created SageMaker, which is our managed machine learning service, just for these types of instances, these types of experiences where we need to make it easier for everyone. And one of the things that I'd love to talk about a little bit, and maybe Jeff, I'll start with you, is with SageMaker, I'm curious to know what kind of training did your developers need on this? How long did it take to get them up to speed? Because many of you in the audience may have never used it. And even though it's supposed to be easy, what did it actually look like for you?
So, SageMaker was announced, I think, end of November, beginning of December of 2017. Shortly after that, we held a little hackathon we were holding the hackathon to experiment with the ability to predict something. But we used a variety of methods to do it. So we had, in the hackathon, we had psychometricians, we had economists, we had data scientists, data engineers, and so on. And we kind of divvied up and we said, well, we're going to take a traditional statistical approach, and then we'll have our existing machine learning workflow go at it, and then we'll have a SageMaker workflow go at it. Now, getting SageMaker going, particularly at that time, there were gotchas. But in any case, we had a short hackathon of a couple days. And I'm telling the story because SageMaker did succeed in earning the highest predictive score, the so-called area under the curve. It was the most likely to predict by a little bit which leads to one of the things I'll tell you about something that I've learned working in this space. But I think the reason SageMaker won is that particularly over this short period of time, it was able to scale up and just permute a lot more. It was just way more computation than somebody could run on their laptop. So I would say, two things we've learned. One is that SageMaker is helpful to data scientists who are already familiar with machine learning as a way of operationalizing something that can be put into production, right? Because it affords you that. Then there's the other thing that it promises, which is democratizing machine learning to people who don't have a data science background. I think that has promise. I have seen less of it so far.
Mm-hmm. Okay. And I'm curious to know, either Noah or Brian, when you first started in using SageMaker, or you had teams who were using it, how long did it take to have them get up to speed and actually begin to start using it?
I was the one who first kind of pioneered the SageMaker at EAB, the use case for that. It took us about a week and a half to kind of get up to speed with the terminology and understanding the documentation. And at the time, it had just been released, and there weren't a lot of features to kind of worry about. It was really just, you had an endpoint and you had a model, and you could score, you could train. There were notebook instances we used to develop, but there wasn't a lot of bells and whistles, especially not the batch scoring processes that they have today. And so we had to build a lot of infrastructure kind of on top. And so we went with Lambda. We wanted to kind of make sure everything kind of scaled as much up or down as we needed along with SageMaker. And it took us some time to wrap our heads around some of the gotchas, right? We had to worry about how many requests we were sending at one time. We didn't want to overload the endpoint. But we worked past them. And then as we were developing all of this kind of in-house infrastructure, SageMaker was actually also developing a bunch of stuff alongside us and solving a lot of problems, either kind of just as we were solving them, or if not a little bit before, a little after. And it was really nice to kind of see us kind of arrive at the same conclusions completely separately, and then coming back together a year later and saying, hey, what have you learned? How does this work now? Oh, look, this feature's now been operationalized, and we can sunset this whole legacy system and just push a button.
And did you start using it in 2017 as well?
It was right after it was released, so like
okay.
a few
Okay,
months
so
after.
lucky, any of you who did not start in 2017, you get to know that it's been advancing continually, which makes it a lot easier.
It's way better now,
Yeah.
but it was great before too.
Yeah, thank you. And Brian, what about
Sure.
you guys?
So I have a perspective on SageMaker. We made a hire in the beginning of 2018 that had been someone who just had received a master's degree coming out of college at the University of Georgia, one of our customers, and actually was just exposed to SageMaker, and he was just completely amazed at how productive, and actually I was as well, about how productive he could be. And there's a couple things that I think AWS did right. First thing is he used tools like Jupyter and other tools, PyTorch and some of the libraries, MXNet, all those type of things in college, but just like a lot of things, the educational experience was a little bit behind the commercial experience. So he was, looking to how he was going to get the data and everything, which comes back to our data platform, which was great for him. But he was just amazed at how productive he could be coming out of that college experience where you're dealing with hidden layers and you're dealing with all the libraries, you're writing all this Python to do stuff, whereas he was able to bring the tools that he had used into that platform and be able to really become productive. I think everyone in the company agrees much faster than any of us thought. And then from there, we are using that for the research function. And then we also wanted to commercialize how we're going to do the production stuff. So things like scheduling data for ingestion, because higher ed's a cyclical business. So, and then on top of all of that, one of the things we were able to do with the platform is make it off and on when we needed it, so we could optimize cost, which we're always trying to do. So we can kind of turn it on, turn it off, ingest data, and all that. So I think the productivity goes through the roof when we got to a platform like that. And the idea that you can bring the tools that that he was used to that, like you do with all your services or a lot of your services where you can bring your own tools, is really something that's unique about AWS and about SageMaker.
All right, so really interesting to hear about how you all got started, what it felt like. There were some gotchas along the way. A couple of you started in 2017. Brian, your team started in 2018. Okay, so now you've been using it for a while. And what I'd love to hear, and I'm going to ask each of you this, is what has it been like? How has using the ML and the AI, how has that impacted your group? And then also with that data analytics, how is it impacting beyond your group? Because I'm assuming there's a change in the group, but it also impacts beyond. So Noah, I'm going to start with you, please.
I'll talk a little bit about what we're working on right now. We are trying to build an API system for data warehousing for universities. And just recently, I think it was yesterday, they had another hackathon, as you were talking about, with SageMaker, trying to enable our analysts and our marketing professionals and pretty much everybody at the company, regardless of what their job title was. They didn't have to be a data scientist, they didn't have to be a developer, but the goal was get your feet wet. Dive into the data, try to figure out some new way of organizing things such that it gives a new insight to whoever your stakeholders are. And when it comes down to it, I'm really glad you brought up the point about cost. Cost control is huge for us.
Right.
We used to outsource all of our infrastructure management to third-party vendors, especially for machine learning, who were then spinning up instances in AWS's cloud and were charging us for those on top of everything that we were paying them on a yearly subscription rate. And we said, that's crazy. Let's just bring it in-house, especially with SageMaker and other ML tools that Amazon has. We ended up cutting down our annual subscription fees from $80,000 a year to $10,000 a year. To score one school, I think it costs about $5 for 3 million students in terms of Lambdas and SageMaker costs. That was just night and day differences. And when it comes down to it, SageMaker and other ML tools like that are really enabling us to kind of move past the traditional, like, oh, data science is a black box, right? For us, we have a standard Docker image we upload, and anyone who needs to run a model can customize it, train the model, and spin it up on SageMaker without too much difficulty. To create a new model, it took us a couple of hours. And so now we've enabled all these different teams across the organization to kind of partner together and really learn from each other and how the data works and can recombine to deliver new value. And we're kind of pushing this whole new course demand system as a result of it. It came out of the hackathon.
So I just want to point out that you said you have a lot of different teams that are now actually looking at the data and all collaborating together.
That's right.
Which I think is really key to starting to understand what does the data tell us, especially when we're talking about students and all of that. And I love your metrics around how much it saved you. When you talk about the hackathon, I'm really curious. You said it was not just your data scientists, but it was other people as well. Were you strong-arming them to do this, or how does that work, that you get people who are not data scientists?
We strongly encourage people to participate, but it really was, if you have an idea, sign up. And a lot of people, we've done hackathons in the past, and a lot of people want to participate but don't know how or don't feel like they give value compared to like a developer who can stand up a web application or a front-end guy who can make it look really nice. And so they're afraid to kind of get involved, and we kind of threw away the rule book on this one and said it doesn't matter what you do. There will be a spot for you, and we kind of help them kind of work through understanding, here's your role, here's what you're good at, here's how you would be valuable to the team that you're working for. You don't just need to be data analysis, you don't need to just be working on the machine learning model, you could be working on the presentation. How you present the insights that you learn about is just as important as actually generating the insights. And in terms of what data you have available, how you massage that data is just as important as how you design the model. So all of these different components have to come together to really derive those insights from whatever it is you're trying to answer.
Yeah. So Jeff, can you share a little bit about how you went from 2017 just getting going to how the department has been impacted and then beyond that?
Yeah, and I should mention we were doing machine learning before SageMaker, right?
Perfect.
SageMaker has been for us like a great tool for operationalizing things. I would say that the theme that I'll strike is the theme of mundane value. Okay, so and here we're not just talking about models you may generate on behalf of customers, but models that you're generating to do internal things as part of just general software. So I'm going to assert, or we are asserting, that we think software engineering and machine learning are going to fuse together, and particularly that all the business logic, which comprises a big chunk of organizational code in every organization, much of it will be susceptible to machine learning approaches. So that's why I want to go back to my theme of mundane value, is that it's not like a lot of times when people think about artificial intelligence, they think about an artificial agent with which they might be interacting, something from a futuristic movie. But the kinds of value that we're seeing are much more practical things, and I'll give you a few examples. So when a user is inputting information, they make a lot of mistakes. We administer standardized tests. Sometimes students will make a mistake in identifying themselves in their own name, in their birth date, et cetera, in their school. It's very common for parents to enter their own birth date instead of their child's birth date when they're registering them for something. And so we can see all these many patterns of errors that happen and essentially correct for them in advance. You could call it error forgiveness, right? That's a practical thing that has implications for data quality, but it also has implications for the experience of the individual educator or student. So maybe not the sexiest example, but nevertheless super practical and valuable. And we have a number of those that essentially are about dealing with data quality. We have something we call the George Foreman problem. And you might guess that that's when you have multiple siblings in the same family who have the same first name. And it's more common than you think, okay?
Can I just ask, is there anyone here who has a family where they all have the same first name? All right.
I happen to know there is one, but she's not going to raise her hand.
Oh my
That's
gosh, okay.
But it is also not common for twins to have the same first and last name, which is really tricky because you want to use that birth date to disambiguate them,
and that doesn't
work. They have the same birthday, right? And beyond that,
that's pretty tricky.
Yeah, it's tricky. They might have the same middle initial as well, right? And it's only the full middle name that allows you to disambiguate them. So that's like a tough problem, right? And it's a ground truth problem that we deal with all the time. And it's in that general category of a data quality improvement. It adds a lot of, if you're one of those two twins, it adds a lot of value for us to be able to ensure that you two are not the same person. And so that's the kind of thing that's susceptible to.
Well, and as a parent, I'm counting on you, if I'm having my twins take the SAT, that you're going to make sure that you know who did what. So this becomes very important and very precious. So yeah, very important. And what about in terms of how it impacts beyond just your group? Have you seen changes at College Board because of your use of ML with SageMaker?
Yeah, so I think all of our programs are benefiting in one way or another. And the way that I think there may be a future time where there's a machine learning engineer on every team. That could be true at some point in the future. Today, our approach is we have a team called Data Science Microservices that collaborates with all the other teams and identifies needs they may have using SageMaker and other tools, and builds those microservices and makes them available in production for use. So that means that it ends up impacting the whole organization. And as it grows, we might have to do more.
Perfect. And Brian, I'd love to hear from you.
Sure. So first off, you did a great job with the panel because we all are at different spaces, and we're more on the starting out phase. So and probably at least a decent percentage of you are in that position. So one of the things that you'll find yourself having to do is sort of sell this and debunk, what the idea that you're talking to a robot somewhere. And so a couple of insights there I think that would help for the discussion. One of them is that we started to look at things that we already do in the predictive analytics space. One of the things that our tools do is help you decide on how many admissions applications to create, for example, in there. And so we were using kind of some standard stats type algorithms to do that. And what we did is we studied if we used some more advanced AI type, ML type algorithms, how we could improve the accuracy of that. And that's the kind of evidence that we were able to bring. I think don't quote me on this, but I think it was something in maybe the 60% range of the actual prediction to what we thought, and we were able to get that into the 80th percentile. So that's still significant, right? 30% or so increase. And then it's taking that back to the business and showing them that, hey, you can improve the accuracy of the products you make. And the same thing with retention, which is also on every higher ed's mind in terms of institutions' mind in terms of not only how many applicants do I have to process into the institution and get the right ones and all of that classification work that can be done around that, but I also have to retain the students that I have, and I have to understand why I'm retaining them or not retaining them. And then more so than that, then over in our systems of engagement, our CRM systems, I go and talk to those folks about, okay, there's individuals that make up these numbers that are being retained or not. And so that helps that tool, which also has the capability to look at retention at an individual basis, and we can also improve the algorithm. So we took these things back to the people that have these products and started with these predictions. And now we're moving into more of the recommendation class and picking, again, using the same model and picking a couple of key use cases in systems that we make. One of them is kind of recommending programs and alternative programs. Another one is recommending course schedules and what type of courses students like you are successful at. So it's that internal, when you got quite a bit of work to do to kind of sell it internally, it's building those use cases that you currently have that you can make better, and then people are like, yeah, I want that to be better, and then from there we can start to look at even brand new stuff. So we have a list called 20 in 2020, which is a more broader thing, but you have to set that foundation in terminology that the business understands. People that'll make decisions and make teams put things into products.
So it's interesting because you start with learning about it yourselves, then you take it to your teams, then you take it to people outside of your own team, but still within the business. And Noah, I want to ask you, because I think we talked about this when we were preparing for this. How has this impacted the ability for your customers to transform themselves? So you've got all of this, but how does that actually get out to your customer?
That's a great question. We started out as a research firm primarily and kind of moved into technology. So our credo is whatever question the customer has is the answer we want to give them. They've gotten a lot more inquisitive as we've kind of dove deeper into all this machine learning stuff. They started asking us questions about all this other stuff that we never even thought of before. So now we're building models left and right, and we're at this point now where we're trying to understand what's really the up at night issues that these institutions are facing, and who are the stakeholders of these up at night issues, so that we can really target these models such that the answers get to the right people. And when you think about improving student retention, when you think about improving pipelines in your CRM system, it's really important to remember that these types of metrics that we're producing need to be actionable. And at the end of the day, the person who's consuming the metric really doesn't care so much about how we got there. They care about why, and they care about if they should act. And when you get to that point, and you say, hey, I should act, and here's why, they feel a lot more confident about not only what they're doing and who they're working with, but also this kind of makes it all the way down to the student who's now engaging with an advisor who's a lot more confident about the path they should take. Or the student now knows that I should take biology and I shouldn't take chemistry in this semester, talking about the degree program stuff that you were just mentioning. The machine learning stuff is almost secondary to answering the questions that the customer has. And now that it's that much easier for us to kind of get at those answers, given the vast amount of data that we're sent every day and all the data that we're generating with our applications, it's about kind of presenting that in a meaningful way, either a dashboard or a metric, or just having a conversation with someone on campus as to what they should be doing and how other institutions are doing it, that really drives the point home, like, this is what you should be doing. Here's why. And we can answer other questions in exactly the same way with exactly the same confidence.
I think it encourages the final end user to actually ask for what they need. And I think up until we had machine learning, you could dream about it, but you really weren't serious about trying to
Right.
get it because there was no way to get it.
It comes down to sometimes the customer doesn't know what they need.
Yeah, that's right.
They know what they want, and what they want and what they need doesn't always jive. And a lot of times, asking the right questions about the data and asking the right questions about why that result is the way that it is actually teasing out not just the answer to their question, but the other question that they didn't know that they needed.
Yeah,
to answer.
yeah. It's interesting because within education, and this is, again, my passion, and I think this is something that all of us up here are very passionate about, the end goal is to help students succeed. And I would love to hear, and Jeff, I'll start with you, on what do you think all this machine learning, all that you're doing, how is this going to finally help students succeed? What's the end game there, and how are you seeing that play out?
Yeah, I think, so I'll answer that with not with a prediction, but with a wish. And so I think that the first thing would be to somehow have an impact on access to opportunity, to educational opportunity. Because at the moment, as you know, our schools are funded locally by local real estate taxes, and that means they're funded unequally. And of course, higher education is also a big investment, and people can't bear those costs equally. Although people do a lot to help them with financial aid, but nevertheless, something that would have an impact there is what I would hope for. A lot of what we imagine the impact of machine learning or AI would be is in direct education, like through personalization, but that's never going to replace a teacher, right, or a fundamental human interaction, which is a big part of education. So I think that I would wish less for like a robot teacher that would do heavy-duty personalization, and more for something that would fundamentally impact access. And I would extend that to include accessibility for people of different abilities.
Perfect, perfect. Brian, how about you?
So I think that, based on the enormous amount of data, and we didn't drop any data statistics on you here, but the enormous amount of data that gets generated today, and I think we all know that, is impossible for us when you even start to look at zettabytes and all that sort of stuff that we're producing on an annual basis, that type of thing, it's unimaginable. So I think where I start my conversation is it's very clear that studying that data is not a human problem. It's not something we can do. So the idea that we can use machine learning to bring that data into play in the education system is what's exciting about it. From a couple of different perspectives. I mean, one of the perspectives is, again, the statistics I'm sure you see every day is around how many people we have to educate to meet the job demands and the career paths and all that sort of stuff in 2020. I mean, in 1940, it was less than 5% needed something beyond high school. Now it's 65% or something like that and growing. So we have to figure out in education how to get more students through the process. That involves optimization. That involves recommendation. That involves prediction. Schools have to be able to structure themselves and be more have more dexterity than they have today to be able to move that quickly. And a result of the discussion you guys had yesterday with George Mason around the first cloud computing bachelor's degree. That's a perfect example, and that's not as easy, well, those of you that are in education know, that's not as easy to put together a new computer science program that's cloud computing, or a new health college or whatever you're trying to do. You're going to need AI and machine learning to be able to do that. And then on the customer side, we'll call it the student, they need more information too. Because right now they approach the education system. I think I should take these courses. I think I should do this program. But we need more power to be able to compare that to career paths and student pathways and all that kind of stuff. And without this technology base, without this being fused into the software itself across the spectrum of products that all of us make and all of you make, we really have an opportunity that we can't afford to not pass up.
Yeah,
that
I
we
think,
can afford to pass.
yeah, and I think that's what's so exciting is that in education, everybody who is in education is there because it is a mission, and we want to bring the best of what we have, and I think machine learning and AI is just going to be a fundamental part of that. So we're almost out of time, but I want to ask one last question that I think probably many who are in the audience who have not done a lot of work with machine learning yet or with SageMaker might want to hear, and that question is, what do you wish someone had told you when you were just getting going on this journey? And Brian, I'll start with you.
Sure. So, I mean, the first thing is I emphasized at the beginning is what does your data look like that you're going to study, whether it's external data or internal data, what do your skill sets look like to be able to match up to that. I wish I would have known a little bit more about that. I think being able to get focused on the cloud, and if you're not focused on the cloud yet to do this, I think it's, I don't know who would be buying a lot of computers and a lot of libraries to do this. I think looking at just what are your skill sets in your institution or in your company, and also what does your data look like. I go to a lot of conferences. I was at a conference recently. I go to a number of AI conferences. They're all about data. So that's something that you really have to think about. Where the data is going to come from at speed and at volume sufficient. I mean, these algorithms, as you know, need huge amounts of data, and they get much more accurate the more data that you have, so I wish I would have known that. And then just, that education process of how you educate your institution around, or your company around how to do this, and what are some of the key points, and as I said, how do you lead them, so to speak, into this, what this means? Because right now, the word AI is an overloaded term. It is that robot, or it is the Jeopardy game, or AlphaGo, or whatever. It needs to become, you need to be able to speak it in terms of whatever your institution or your company is doing.
Perfect. And Jeff?
Okay, so I'll say 4 short things. The first thing is, most of the work is going to be munging. Most of the work is data munging, so you need to emphasize data engineering. This echoes what Brian said. The second thing is, you've got to start from a good question, not a shiny ball. Spend ample time getting to a good question, okay? The third thing is, feature engineering is the whole ball game, and it is an art, and it is not going to be automated anytime soon, and feature engineering involves looking at the underlying data set and coming up with hypotheses about how to structure it in a way that is likely to produce a good result. So for many, many machine learning algorithms, that is necessary to do right up front. And for any algorithm, you're going to benefit from spending the creative time of doing that feature engineering. And then the fourth thing, and this one really is a good one, I think, for managers to grok, is that if you have an existing statistical way of predicting or classifying something, it is likely that machine learning is going to be just a tiny bit better, but only a tiny bit better. Sometimes that matters. If you're doing arbitrage or something, a tiny bit better is fantastic, right? But for other things, a tiny bit better isn't going to please your customer all that much, right? So when you have a traditional statistical approach, like logistic regression or whatever it is, you're probably only going to get a little bit better. But where machine learning can make a total breakthrough is when the data is something that you couldn't do a traditional statistical approach to, like processing photographs, for example, or a hugely sparse data set, something that you couldn't do logistic regression on. So those tend to be the good places to look to find big value.
Mm-hmm. So be careful about where you're starting.
Yeah.
Make sure that you're going to get a lot of bang for the buck.
Yeah.
Got it. Okay.
I will
Noah?
reiterate that it's all about the data. We spend 90% of our time massaging data into the point where we can get it into our model, but once it's there, it's really fast. Everything's automated. So data cleaning, data validation, data aggregation, all these things are important to think about, and that leads me into my second point, which is when you're designing a system, especially a machine learning system, you need to think about performance, you need to think about scalability, and you need to think about reliability of the system. If you try to spit out results they should be reliable, right? They should be the same every time you run it. If you add more data, they'll improve or not, depending on how good your model is. Performance is really important, especially from the data aggregation side of things. We spend a lot of time thinking about ETL from the perspective of, we have these huge files, especially when you're dealing with CRM data. Some of that can be in excess of 20 gigs in a single file, and you're trying to kind of push that through your system's going to get bottlenecked. So thinking about data as streams, improving performance at every step of the process all the way back to data aggregation is really important. And then scalability, when you're designing your system, you don't want to be in a situation like we were at when we first started out, where we could only run 2 models in parallel at any given time. You want to be able to scale out to your customer base as customers ask questions, as you're trying to answer your own questions with your own data. You need to be able to scale that system out to be able to handle any workload and any number of models. And if you do it right in the beginning, then there's a lot less work that you need to deal with down the road.
That's fantastic. Thank you all so much for sharing your insights, and good luck on your ML and AI journey. I appreciate it.